Hello, your kind attention is called to the Gracia computer-aided design system, which is the system of comprehensive automation of the process of pattern design and workflow preparation for production of ready-made garment. Gracia is the open-type general-purpose system used successfully in the sphere of production of all types of clothing, knitted and fur articles, headdress, knapsacks, tents, and leather accessories. The system allows to automate all stages of the preparation production process: development of product outline sketches, construction of basic and model designs, size and height duplication, reconstruction of patterns to match individual figures, development of product manufacturing process sequences and labor division schemes, generation of the optimum product output plans, layout of efficient and practically feasible markers, prime cost calculation, estimation of requirements in materials, production dynamics, and product sales calculations, accounting, planning, and day-to-day management of the production process. Gracia has modular structure and comprise the following subsystems: design, pattern design and modeling, individual and corporative orders, technology of production, layout markers, storing calculation, planning and operation of business. The design subsystem is intended for the development and storage of model sketches in the computer form. To do it, the three basic methods are used. First, generation of product sketch with the use of a common graphics editors: CorelDRAW, Photoshop, Paint. Second, drawing sketches by hand and their input with the help of scanner. Third, digital photography of articles. Outline sketches are stored in the form of files having names of future models and serve as the original product development assignment documents. The purpose of the pattern design and modeling subsystem is to automate solution processes for tasks of pattern design preparation, provide for proper quality of the products in respect of all sizes and heights, assure quick interchangeability of models. The high-tech computer design concepts incorporated in Gracia assure fast-rate and high-quality solution of each of the following pattern design preparation tasks. First, construction of model patterns in base size and height. Second, size and height-wise duplication of patterns. Third, construction of model patterns to fit a particular figure with all size and bearing specifics being taken into account. Fourth, introduction of quick changes to patterns with the consideration of observations that are made after a pre-production model in the event of any material properties or fashion changes. Fifth, redesign of model patterns to fit any other population typology: Asiatic, German, Italian, American, etc. The solution of each design engineering task with the use of the Gracia computer-aided design system is described below in more detail. Construction of model patterns in base sizes and height. At first, the designer generates the tables of body dimensions. The Gracia system has setting tables of standard body dimensions for women, men, girls, and boys. The designer selects a proper table. He may change body dimensions values or produce a new table of standard body dimensions. For construction purposes, the designer enters calculating values as constants, formulas, or tables. Thus, for example, a chest addition value depends on a type of silhouette and chest. The value is set in the form of a table where addition values for different combinations of these parameters are specified. The next stage deals with the base design construction. Gracia is the open type system that sets no bounds to the designer and enables to construct base constructions using any design methods, their combinations, or designer's own methods. The Gracia specialists have already constructed and tested the base constructions of shoulder and waist products with the use of many well-known designing methods. The designer can use one of the proposed base constructions, modify it, or construct his own construction. In practice, the overwhelming majority of designers who use GRAZIA CAD construct their own original, unique base construction, basing on their knowledge and expertise being a part of the brand. GRAZIA CAD introduces the high-tech computer processes implementing the analytical graphics design method. The characteristic feature of the system is based on its ability to produce and store both the construction process, algorithm, and construction result, patterns. The screen is divided into two parts. The right part is used by the designer to make a record of his actions using the resources provided by the system. Those actions may involve generation of points, straight lines and curves, application of design modeling methods, write down design formulas, and conditional situations. The left part of the screen is used to display graphical plots that result from carrying out recorded actions. All actions are based on any designing methodic principles. Recorded on the right side are the actions that must be carried out by the designer, while appropriate plots are displayed on the left side. As required by the graphics design method, all actions are recorded in the analytical form, with each point and each line having an individual name. All the point and line names are specified on the draft. Established between the draft and construction algorithm is the one-to-one relation. The designer shows an algorithm operator, and the system finds and highlights the relevant object on the draft. The designer shows an object on the draft, and the system finds the relevant operator in the algorithm. All operations performed by the designer are automated to the maximum degree. Any designer's action involves two components. Which action, operator, is desired to be carried out, and which objects are to be used. The type of an operator is chosen by the designer in the appropriate list, while the desired objects can be shown on the draft or in the table. For the sake of convenience, all the actions are subdivided into 5 groups. First, actions with points. Second, actions with lines. Third, graphic actions. Fourth, actions with details. Fifth, actions with algorithm structure. To enhance the level of automation and improve control over all designers' operations, the mechanisms of masters was introduced. When a desired operator is chosen in this mode, the master prompts which objects and in which order must be shown to produce this particular operator. If, for example, it is desired by the designer to put a point at the crossing of lines, the designer selects option Actions with Points operator crossing, and following the master's prompts that appear in the lower string of the window indicates the first line and the second line. The names of those lines are automatically entered in the operator being generated. After the operator is carried out, point T96 appears in the drawing at the crossing of the lines that were indicated. The name is assigned to the point either automatically or by the designer. To form an operator of interconnection of two points by a straight line, the designer selects option Actions with Lines, operator segment. In this case, the master recommends that the segment start and end points be indicated. After the operator is executed, segment L208 appears on the draft, which interconnects points T96 and G73 that were indicated. Let the process of curve line construction be considered by the example of an armhole section. The curved line passes the preset points. It is often the case here that an angle in which this line is drawn relative to other lines must be maintained in the given point. The designer selects option Actions with Lines, operator Curve Line. With the master's prompts being followed, the designer indicates sequentially the points and the values of angles therein at which the curve line must be drawn. In point P, the line passes to shoulder line L19 at an angle of 90 degrees. In point P3, the line passes at a tangent to line L8. In point T1, the line passes arbitrarily. In point G2, the line passes at a tangent to line L4. Angle values are disregarded when constructing fashioned tucks, reliefs, and decorative lines. The designer aims to draw a line that would be fine from the aesthetic point of view. To this end, Gracia provides for the graphic correction function. This function enables the designer to draw or correct lines by graphic means. The designer selects operator graphic correction, specifies the line section to be corrected, and alters the form graphically. If a line point is moved with the left mouse button pressed, the form of the whole line will change. If a point is moved with the right mouse button pressed, the form of the line section in the vicinity of this point will only change. The system will automatically calculate and record the formula of the line drawn and reproduce it for all sizes and heights. The designer records sequentially while the system executes all actions to construct the back and fore part. The sleeve drawing can be constructed on this list or on another one. While constructing the sleeve, the link between the sleeve rounding line and armhole line is recorded and provided for. There exist two types of links. First, when constructing a sleeve rounding line, the designer makes use of the armhole section lengths. As the length of the armhole line changes, the sleeve rounding line length will also change. Second, while constructing the sleeve rounding line, the designer copies some armhole sections and adds them to the sleeve rounding line. As the armhole line changes, the form of such sections on the armhole and sleeve rounding lines will become coincident. Having set necessary conditions for sleeve rounding and armhole line construction linkage, the designer provides automatic changes of sleeve construction in response to armhole line changes. Linkage for construction of all mated, delivered, and auxiliary module patterns is set and maintained in a similar way. The construction linkage is very important for automation of the designing process. At the same time, it may be implemented in neither graphical system. The designer builds up gradually all necessary points and lines of the draft. Using the design modeling techniques, tuck carryover, allocation of additions, construction of relief, the designer develops details of model construction. Let us take a lady's jacket as an example to consider the straight relief construction process. Set the relief starting point along the shoulder line. Carry over the chest tuck. Using operator curve line, produce the relief line of the central forepart. Create the relief line of the side forepart. Similarly, construct the back relief and broaden the article downward. The next step is to highlight details on the draft. To do it, the designer selects option Actions with Details, Operator Detail, sets the name for the detail, and indicates sequentially points and lines of the contour of the detail. The system records the name of those points and lines, highlights the part in a different color, and enters it in a list. All other details are highlighted in a similar way. Using Gracia's convenient tools, the designer constructs the details of lining, fusing, enhances, weld, etc. To construct lining details, it appears convenient to copy the top details to a separate list and transform them as required. The next step of the process deals with the construction of pieces on the base of details. To do it, the designer must set, for particular sections of the detail, the necessary seam addition values and methods of forming of angle sections. Depending on the manufacturing techniques, characteristic features of the equipment used, and types of workings, the draftsman selects operator seam, indicates the initial section point, sets the seam addition value as regards the given section, indicates the final point of the section, and chooses one of the 23 alternative methods of angle forming therein. Basing on the set conditions, the system constructs the piece contour line. The detail line can be stored and used as the seam line. The methods of forming of draft angle sections were developed with the participation of Olga Surikova, the associate professor at the Ivanovo State Textile Academy. Acting in sequence, the designer produces the complete set of the drafts: top drafts, lining drafts, auxiliary drafts. So, the designer has completed the construction of drafts in base sizes and heights, and thus has solved the first task according to his liking and ability. This is the creative process. The system is responsible to a considerable degree for the solution of the remaining tasks, performance of technical, routine operations. The work is carried out at a fast rate and with great precision. Second, the next design task is focused on duplication, that is, the construction of drafts having required sizes and heights. There exist Two basic pieces duplication methods: construction of drafts in each size and height, and gradation of pieces. First, the drafts are constructed in each size and height separately, with the use being made of appropriate body dimension values. In order to construct drafts of each size and height, the operations that were carried out when constructing base size length drafts must be practically repeated. This method allows to provide for the adequate quality of the product in all sizes and heights, but is time-consuming enough when applied under manual work conditions. Second, the gradation method is concerned with obtaining drafts in other sizes and heights from the base size and base height drafts by setting increment rates in construction points. Drafts of other sizes and heights are produced by increasing or reducing proportionally the base size and base height drafts. This method is approximate, brings about draft mating distortions, results in failures of fit and balance characteristics, deterioration of product quality. The more the size differs from the base value, the more significant distortions are. The gradation process does not consume much time for duplication, but instead it takes long to check and correct pieces. Gracia is able to solve the duplication task rapidly and accurately. The designer selects the model command and sets the range of needed sizes and heights. The system executes the construction algorithm for each size and height with the use of appropriate values of body dimensions taken from the table of standard body dimensions, constructs drafts of each size and height, and stores their forms. Thus, the draft duplication task is solved in the Gracia computer-aided design system in the automatic mode through reconstruction of pieces for each size and height. After having constructed the drafts within the preset range of sizes and heights, the system provides for an option to view the pieces in a certain size and height, or enables to see straightforward how the piece is constructed in several sizes and heights. Desired size and height values are selected thereto in the duplication grid. In order to check the product quality in respect of all sizes and heights, the designer is provided with an opportunity to indicate in Gracia controlled values of interest and set the method to measure them. Thus, for example, the draftsman sets the following values: the sleeve rounding length as the distance between points P21 and P11 along line L141, the armhole length as the sum of the armhole section length at the back and the armhole length in the forepart, the sleeve fit as the difference between the sleeve rounding length and armhole length. The system will measure those values automatically in each size and height and will enter them in the table of control measurements. Besides, the system will be able to complete automatically all required supporting documents, calculate areas of the drafts, and draw up their specifications. For this purpose, a type of document to be generated should be chosen in menu Model. After this, It will take the system several minutes to complete the document. Draft shapes may differ considerably in different sizes. The draft construction specifics relating to each size and height are taken account of with the help of conditional operator if then else. The operator offers the draftsman ample scope of various opportunities, enables the designer to describe conditional logical situations and actuate automatic execution modes, arrange for intellectual designing processes, and create knowledge bases. For a specific example, let us consider conditional operator if the total tax opening is above 5 centimeters. Then construct 2 tacks in the back cloth, otherwise construct 1 tack. The operator will analyze in each size the value of the total opening of the tacks and, depending on this value, will provide for relevant constructions to be made. Thus, for size 96, the tack opening in the back cloth exceeds 5 centimeters, and therefore 2 darts were produced by the system. As regards size 92, the tack opening in the back cloth is below 5 centimeters, and therefore 1 dart was constructed by the system. The third designing task: construction of pieces to fit individual figures. This task is faced by enterprises that specialize in execution of individual corporate orders. Corporate clothing finds increasingly more extensive use. It includes wear for sportsmen, security structures, personnel of different ministries, establishments, and organizations. The high quality of the products and mobility of their development often serve as the key factor in winning tenders for manufacture of corporate clothing. Using the Gracia's resources, the designer is able to develop algorithms for construction of product drafts in one size and height. While constructing the base algorithm, the designer normally singles out 9 or 12 typical body dimensions, which determine peculiar features of a man's figure and specifics of a given article. To reconstruct product drafts to fit an individual figure, an appropriate algorithm should be executed with the use of the body dimensions of the man and consideration of his wishes. This process takes about 1 or 2 minutes and allows to produce articles without their trying on. Gracia is provided with subsystem, individual and corporate orders, which was specially developed for the purpose of implementation and maintenance of the client's measurement database and computer-based catalog of articles. Such system of servicing gave a good account of itself in the course of execution of individual orders. When an individual client comes, his data and body dimensions are entered in the client's base. When selecting an article in the computer-based catalog, the client will be able to see how the article looks on the model figure as well as on his figure, and will be able to advance his wishes. Let the individual measurement values be loaded in the model that was chosen, and the system will reconstruct the pieces to comply with individual body characteristics. Apart from conventional meter-measure rulers, the Westing sketch method and the devices for contact-free obtaining of data on men's figures are successfully used to take measures. The fourth task: introduction of changes to pieces with the consideration of observations that may be made after a pre-production model is ready, also in the event of any material properties or fashion changes. The efficiency of development and fast-rate changeability of models depend essentially on the adequate solution of this task. The Gracia system provides for a quick and high-quality solution of this task, which is, first and foremost, due to the factor of interconnection implemented in the details construction process. It would suffice in most cases to alter the values of additions, parameters of design concepts. It will only take a few minutes to produce new drafts as a result of re-execution of the algorithm, with the count being taken of all changes that were made. The Gracia system features a range of design facilities which allow to provide for the adequate quality of products and reduce significantly the time for their designing. Let some of those facilities be considered. First, mating control and correction. Gracia enables the mechanism of automatic control and correction of details mating to be used in each size and height. To this end, relevant actions should be written in the base algorithm. For example, in order to provide for mating of the neck orifice sections in the back and forepart and armhole mating along the shoulder line, the designer copies the back neck orifice section and mates it with the forepart neck orifice section along the shoulder line. Then the designer draws the new single-piece curve line of the neck orifice. The neck orifice section, so corrected, is made a part of the back contour. One can also provide for mating of armhole sections in the back and forepart. The mating correction will be made automatically in each size and height, which will ensure high quality of the product. Second, implementation of modular designing method. Any logically completed construction process can be singled out in Gracia as a separate module having input parameters. In order to use such module, it would suffice to indicate its name and specify the input parameters. Example: the band color construction module has the following input parameters: color height, neck orifice line length, and band to neck fit factor. In order to construct a particular color, one should set the color height and fit factor, specify the length of the product neck orifice line. Then the system will construct the color according to the preset parameters. The designer will gradually accumulate the module base, modules of construction of base designs for different kinds of silhouettes and cuts, modules of construction of different types of sleeves, colors, pockets. When analyzing a designer-produced outline sketch of the article, the designer gives accent to certain art design features of the article, calls needed modules, defines parameters more precisely, in order that the system may be able to construct drafts. This allows to implement a modular approach to the designing process and raise drastically the productivity of labor. Third, organization of intellectual cyclic processes. Basing on the algorithm, the armhole is constructed, the sleeve is constructed, the actual fit and the fit inaccuracy are determined. If a fit inaccuracy is below the permissible value and, for example, is equal to 1.5 centimeters, the process of construction is continued. Otherwise, the fit correction algorithm produced by designer will be executed. The sleeve width and rounding height will be changed by a small value, the sleeve will be reconstructed, and the fit inaccuracy will be re-estimated. These procedures will be followed until the desired condition is met. According to the statement made by specialists of the Ivanovo State Textile Academy, Gracia acts in this case as the intellectual assistant to the designer. Fourth, any sewing product presents the result of combined work carried out by the designer, pattern designer, and technologist. The Gracia system gives careful consideration to the task of generation of the environment that would be able to ensure their creative interaction. One of those important features is the connection between the product draft and pattern design. Using a sketch, the designer can adopt such art design features as a kind of silhouette, cut, sleeve, and color type, etc. But apart from it, one would wish to apply parameter values, proportions, form of certain lines. This would call for the technical outline of the article, or more exactly, the article draft. In the Gracia Moscow Center of High Computer Technologies were produced the modules of construction of figure projections based on body dimensions, mannequins. Basing on those figures, the draftsman constructs article draft in base sizes and design patterns of article. The system constructs article draft in all sizes and heights according to typical body dimensions and drafts. Prior to have an article sewn, it has become possible to see and estimate how the article will look on a figure in different sizes and heights, determine in which sizes parameters and proportions need to be changed to make the article look harmoniously. Example: let the skirt length be considered and estimated. It may be left unchanged in medium sizes, reduced in small sizes, and increased in large sizes. Reconstruct the model to match size 88 and height 170. Reduce the length of the skirt. Assess the article appearance considering changes made in respect of a given figure. Reconstruct the model to match size 104 and height 152. Assess the appearance of the article, make appropriate corrections, that is, increase the length of the skirt. The system will construct a model having new parameters. The designer will just need to enter changed values for the system to be able to reconstruct the drafts with the consideration of such changes within a few minutes. The fifth task, reconstruct model drafts to fit any population typology, Asiatic, Canadian, American, etc. Large companies and fashion houses produce clothing for many world countries. The typology of figures of people living in various countries are far different. One must take account of those differences and hence one has to keep additional staffs of draftsmen. Gracia allows to solve this task on a new qualitative level. One should produce the tables of body dimensions relating to different population typologies and execute the base algorithm of article construction with the use of appropriate body dimensions. Example: jacket for Russian ladies. In order to produce drafts for a chosen model relating to some other typology of population, it will suffice to load the table of standard body dimensions relating, for example, to Chinese, and the system will reconstruct the algorithm basing on the new body dimensions. It won't take you more than a few minutes to produce ladies' jacket pieces to fit a standard Chinese figure. One can also load the table of standard body dimensions relating to a different population typology, for example to that of Italians. In this case, the system will reconstruct automatically model patterns to match the body dimensions of Italians or any other population typology. It won't take you more than a few minutes to produce ladies' jacket drafts to fit a standard Italian figure. Conclusive remarks. First, the Gracia system employs the high-tech computer-based designing principles enabling to implement the classic design graphics method. Second, the system provides the designer with ample opportunities and has been designed to implement the comprehensive automated process of solving all design preparation tasks on a new qualitative level. Third, the system sets no bounds to the designer, letting him to be involved in creative domain, while all technical and routine operations are performed by the system. Fourth, Gracia may be applied effectively both for operating and training purposes. Today, Gracia specialists are trained at 35 institutes of higher education, 22 colleges, and 7 lyceums in Russia, Ukraine, Belarus, Kazakhstan, and Moldova. The system conforms to the science and practice requirements. Fifth, it's preferable but not binding for those who wish to master Gracia to be conversant with computers. The essential thing is to be a designer. During the first week of the work, the designer will grow familiar with Gracia's operating techniques and besides will be able to design 2 or 3 products.